Right. Hopefully you guys can see my screen. So I'm Anuda, I'm a freshman studying computer science. And today we're gonna be talking about Flutter and how we can basically build cross-platform mobile apps using Flutter. Okay, so to start off, we're gonna have a quick poll. So I want to know what mobile OS you guys use. So if you go in the participants window, if you use Android, you can click on the yes button. And if you use iOS, you can press the no button. And if you use something else, you can press the raise hand button. A few more seconds to get everyone's response in. So yes for Android, no for iOS, raise hand for anything else. Okay, so it looks like a lot of you guys use iPhones and iOS, and a few of us use Android as well. But as you can see, no one uses anything other than Android and iOS, and that's kind of part of my point. So this is basically the mobile OS market share from 2019 worldwide. And as you can see, close to almost everything is basically either Android and iOS. So what this means is if you're going to build a mobile app, you have to have your app for both Android and iOS. You can reach everyone. So Flutter is a solution that helps you build your apps easily for both Android and iOS without having to deal with native app development. So the main reason that Flutter exists is because you want to reach both Android and iOS, and because native app development is a big hassle. Because with native app development, you're going to have to deal with different technologies and languages. If you want to build for Android, you need to know Java or Kotlin. And if you want to build for iOS, you need to know Swift or Objective-C. And the other thing is if you want to build native apps for both Android and iOS, you have to follow different user interface and user experience conventions based on the specific OS and based on the specific design conventions that each operating system has. And the other thing is you have to develop apps that can meet different screen sizes. With iOS, there are a few close to 10 or 15 screen sizes. And then if you look at Android, there are millions of screen sizes. So just dealing with making your app work well with all these different screen sizes is also a big hassle with native app development. And finally, the biggest challenge, I think, is just having to maintain two different code bases. If you want to push new features, you have to build the same feature using two languages, using two technologies. And if you have to fix some bug in your code, then you're going to have to do that twice. And essentially, everything you need to do has to be replicated if you want to use native app development to develop any mobile app that you want to develop. So Flutter solves most of these problems, and it does this by letting you create Android, iOS, and web apps all from one code base. And the good thing about Flutter is in addition to letting you compile Android, iOS, and web native apps using one code base, it also makes sure that all of the user interfaces you build automatically follow all of the design conventions. And we'll dive a bit deeper into how exactly this is done. But just know that as this GIF shows, a lot of the UI elements just automatically follow the design conventions of each operating system. So in terms of how exactly Flutter does the cross-platform development, basically what happens is you write your code in Dart, and then when Flutter compiles this code, it compiles it into native Android code in Java or Kotlin, and then it compiles it into native iOS code using in Swift or Objective-C, and it also compiles it into native web app code. And like I said, the language that Flutter uses is Dart, and Dart basically is an object-oriented programming language, and what this means is basically it's a class-based language. And a good thing to know about Dart is that it's garbage collected. And if you probably wouldn't have used Dart before if you haven't used Flutter. Basically, Dart is not that difficult to pick up because the syntax is very similar to C or Java. Okay, so now that we know a little bit about why Flutter exists and what Flutter uses in terms of the language and how it exactly compiles code into Android and iOS, I just thought it might be interesting to look at some companies that use Flutter. So I don't think I mentioned it before, but Google is the company that built Flutter. And a lot of their apps use Flutter, and also a lot of big apps with a lot of users use Flutter because of its simplicity and because it's much easier to reach a bunch of different operating systems using Flutter. Okay, so the goal for today is going to be to go over an app that I built using ScottyLabs Course API. So the initial plan was to actually build the app during this talk, but because we don't have much time, I already have the app built. We'll just be going over each of the different components of the app and how we can build different functionality into using Flutter. So we'll talk about how you can install and set up Flutter while we do this. We'll talk about how you build UIs using Flutter while we talk about how this app's UI is built. And then finally, we'll talk about how you can integrate with REST APIs by talking about how this app is integrated with the ScottyLabs Course API. So if I can quickly demo how this app works, just so you have an idea. So basically, it's a simple two-screen app, and this is basically the home screen. It takes in a course number, and then when you search for the course, it basically calls the ScottyLabs Course API and then gets some information about the course, and then displays it to you in a second screen. And then you can go back and search for any course at CMU, basically. Okay, so firstly, when it comes to installation and setup, I won't really be going over all of the details, but Flutter has some really good documentation, and it basically talks about how you can install Flutter regardless of your operating system. And it also talks about how you can get Flutter set up for any editor you like. Most editors have plugins that allow you to use Flutter and Dart. And then, so later on, when you want to go over the code, if you want to run it on your own machine, you can go into this link and then install Flutter. So once you install Flutter and get your first project started up, there are a few things that you should note about your project structure. So the first thing is there's going to be this file called pubspec.yaml. If we go into the code here, it's this file. And this is basically a configuration file of sorts. And it's where you manage all of your assets, your dependencies, metadata. And whenever you basically include any new dependencies or assets, you need to run this command, which is flutter pub get. And this will basically reload and update all of the packages you have in your project. And then the Android directory is basically where all of your native Android code goes when your app is compiled. So if we go into the project, and you might recognize the project structure of this if you've done any native Android development, but this has all of your Gradle files, your manifest files, anything, all the things you would expect if you were building an Android app is in here. And you can, you'll have to edit it later on if you're going to be deploying your app to the Play Store. And likewise, the iOS directory has the native iOS code, and this also has an Xcode project file that you can open up in Xcode if you're familiar with the iOS native side, and if you've actually went to the talk before this one. And you'll need to once again go into this later on if you're going to be deploying your app to the App Store, but we won't be going into that today. But just it's good to know that these two directories have the Android and iOS parts of the app, and then the pubspec.yaml file is for the configuration stuff. And then finally, the lib directory is basically what we're going to be working in. It's where we write all of our Dart code. So in this case, I have a few Dart files, and we'll go in depth into exactly what each of these files do. But yeah, all of these files inside the lib directory is Dart. Okay, so to start off, we'll be talking about how you build the user interface. And when it comes to Flutter, basically it's all about using the toolkit that Flutter provides. And it makes it really easy to build beautiful user interfaces using their UI toolkit, even if you have very little experience when it comes to UI design or front-end development. So the big thing when it comes to the user interface in Flutter is basically understanding that everything is a widget. So the main reason why everything is a widget is because Google and a lot of app developers run into this problem because cross-platform UI elements is a big challenge. Like I said, you need to have your UI elements meet the design conventions of different operating systems, and you also need your UI elements to meet the different screen sizes of different operating systems and different devices. So all of these problems are aimed to be solved using this widget-based user interface design solution that Google have implemented with Flutter. So basically, Flutter comes with tons of different pre-built widgets, and each of these widgets automatically adapt to different screen sizes. And all of the widgets also follow all of the different platform-specific design conventions that you would want your app to meet. So for example, if you include something like an alert dialog in your app, as a Flutter developer, it's just going to be one alert dialog widget. But then when it actually gets compiled into iOS and Android, the alert dialog will look different for Android users and iOS users based on what the specific design conventions of Android and iOS alert dialogs are. So if we go into the widget catalog, it's quite extensive, and it basically has all of the different widgets you would expect as an app user and as an app developer. So basically, because Flutter has provided all of these different widgets, as a developer, you don't need to reinvent the wheel. All you need to do is basically take these widgets and use them kind of like Lego blocks to build up your UI. And the next thing is after you use all of your widgets, basically the thing you need to understand is that every screen or page is basically a widget tree. So you have all of these objects that are called widgets, and they're kind of like your Lego blocks. And if you used, if you've done any CS classes before, you probably know what a tree is. But basically what happens is you start off with a blank canvas, and then you include widgets, and then you can have widgets that are children of other widgets. And that basically creates the entire UI, and that creates the entire screen. And we'll go into detail about how exactly that widget tree is created when we look into the code and look into how the course API's UI is built. So the next thing we need to know about is basically the concept of stateless versus stateful widgets. So stateful widgets are basically widgets that respond to user interaction. So these are things like checkboxes, navigation bars, app bars, buttons, anything that needs to change its appearance when someone interacts with it. And then the stateless widgets are basically static widgets that don't really change. So these are things like cards, icons, text, titles, and you can look into the documentation and the widget catalog, and it'll actually go into detail about what each of the widgets are and whether they're stateless or stateful and how exactly you can use them in your Flutter projects. So when we look at the widget lifecycle, so you have these things called widgets, and that's how you build the UI. And then you have, so some widgets are stateless and some widgets are stateful. And then when we look at the widget lifecycle, Flutter gives us a few methods that we use to actually build our app using these widgets. So there's a method called create state, and this is basically called when a widget is created, and this is done by Flutter's end. And then the init state is basically a method that we can use to initialize data once a widget is created. So if you want to, for example, call some API and then show data that you get from that API as soon as the screen is built, then you would put that in init state. So as soon as before the widget is even created, you have the data that you want to show on your widget. It's already initialized. And then the build method, this is a really important method that we have to have in all of our pages. And this is basically the method that we use to paint the widgets on the user interface. And then so all of these three methods are available for both stateless and stateful widgets, but then the set state method is basically a special method that we get for stateful widgets, and it basically allows us to tell Flutter to repaint the widget on the user interface when something changes. So for example, in our case, when someone presses a button, and if you want to show some image or if you want to change some text on the screen, then we would have to call the set state method to tell Flutter to call build again and then show whatever change, to basically show whatever change is made on the UI. And then finally, the dispose method is called whenever a widget is removed, basically. And this is done by Flutter automatically. We don't need to worry about it much. Okay, so the next thing you might wonder is how we can navigate between screens and pages. So basically in Flutter screen pages are called routes. And basically to switch between screens, we use the navigator stack. So you might know what a stack is. Basically, to go back to the previous screen, you just use the pop method. And then to push something and to move to a new screen, you use the push method. So we'll talk about, we'll look into some examples about how exactly we move to a new screen and what exactly we need to pass to the push method when it comes to navigating to a new screen. And then finally, if you want to pass data between screens, then you'll have to include constructors in the screens. And just like with any other OP language, we'll look into that as well in our example. Okay, so now we'll dive into the code and talk about how this UI is built. So firstly, when you create your project, you're going to have this main.dart, and I haven't changed it in this case. I've just basically said that when the app starts, I want to go to this screen, the new home screen class, and that's going to be in the home screen Dart file. So here I have a stateful widget, and if we look at the build method, so this is where I'm actually returning the user interface for this specific page. So this is the place where I actually build the widget tree for this page. What I'm doing is I'm returning what's called a scaffold. And if you look at the documentation, a scaffold is basically just like a blank screen with a app bar that you can then build stuff on top of. So inside of the scaffold widget, I've specified an app bar. So again, the app bar is another widget. So I've created a new app bar. And then inside the app bar, I've specified a title, which is again done through a widget. So here, you might visualize this in a tree by saying, for example, a scaffold on top, and then an app bar inside of below the scaffold. And then inside of that, you would see things like a text widget. And then inside of the body of the scaffold, I basically have a padding widget. And what this does is it basically adds padding all around the app. So I have 12 pixels set here, 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 and here. And then inside of the padding widget, basically, I have a child node, and that's basically a column widget. So the column widget allows you to basically have a column of different widgets. So it's done through basically like a list of different widgets that you specify as the column's children, and then that gets painted onto inside of the column. So here I have a text field widget. And this is going to be taking in a number because we're going to be typing in course numbers. And if I actually go into the, if I display the keyboard on the iPhone, it takes in numbers only. And then we have to specify a controller when it comes to text fields, and this will allow us to actually capture the data that's inside of the text field. You can read about this in the documentation. It'll go over exactly how you do this inside of the text field widget documentation. It's not too complicated. And then I've included a decoration widget basically to specify a placeholder. So I say enter course number here. And then right below that, so this is still inside of a column, I have another padding widget. And then right below it, I have what's called a raise button widget. So that's the search button. And in here, I basically specify things like its color, its color, what the text inside of it, and then I have some final, final padding widget below it. So you might notice that this bit of syntax specifies two different things for each of these aspects of the widget. So when it comes to color, what I've done is I've basically set it so that when it's looking for something in the course API, it changes to blue, and it changes the text to loading. So the way I do this is I have a Boolean called loading, and we'll talk about this later on when we talk about how the API was integrated. But basically what it's doing is I'm using this ternary operator to change the color based on if this is true. So if loading is true, then it's going to be displaying blue. And if it's false, then it's going to be showing the red accent color. And likewise, when it comes to the text actually displayed on this, inside of the button, it's going to be displaying loading if loading is true, and search if loading is false. So loading is basically just a Boolean, and this is one of the ways in which you can have your UI elements respond to different parameters inside of your code. And then if you look into this next page, so I have it in a different Dart file called course screen. And this is a much more simple widget tree. It's again just a scaffold, and I have an app bar. And this time I'm displaying the course ID inside of the app bar. And then inside of the body, I have a column, again, a list view in this case, and it has a card. And I've specified how rounded the corners of the card are. And I have basically all of these text elements inside of text widgets inside of the card. So you can see it's very easy to build UIs using Flutter because all of these things like cards, text elements are already pre-built. So I didn't have to spend any time actually specifying what a card should look like and how exactly card should be built. It's just, I just specify that I want a card here, and this is what I want the card to include. And I just changed one thing about the card, which is basically how the border radius, how rounded the corners are. And then if we talk about how exactly I move between the pages. So I talked about the navigator stack before. So basically, when it comes to moving between the pages, I'm using this navigator, this push call to navigator. So I'm basically passing in what's called the context. So this is basically telling Flutter where you are in the app. And then this right here is basically telling Flutter to create a new route to the course screen class, which is inside of here. And then because I need to pass in the data, we'll talk about this later on when we talk about the API integration. But what I'm doing is I'm passing in all of the course data, all of this information into course screen as a constructor. So I have specified a constructor inside of this class that takes in course data. We'll go into detail about what exactly course data is a bit later on. Okay, so are there any questions about the user interface in general and how you go about building user interface? I know it's a bit high level, but if you have any questions, feel free to ask. No questions? Okay. Okay, so basically, since we've talked about the UI, the next part is to basically talk about how exactly we're going to be calling the course API. So if you haven't worked with an API before, basically an API is an app running on the internet that allows you to exchange data between your apps and services and some other app and service that's running externally to your service. So in this case, we have the course API by ScottyLabs. And basically what it allows us to do is basically make a GET request to this endpoint, and it takes in the course ID as a URL parameter. And then after that, it responds with a bunch of different information about the course. So if I type in something else, it'll respond accordingly based on the course ID that I provide. Okay. So when we actually implement API integration in Flutter apps, there are two libraries that you need to specifically know about. So the first thing is the HTTP library, and this is basically for making REST API calls. So the HTTP library supports get, post, put, delete, and all of the other features and functionalities that you would expect from that'll allow you to basically integrate with the REST API. And then the async library is basically needed for the async functions that we use when we use the HTTP library. So async specifically gives us a keyword called await. And this allows us to tell Flutter to basically call the API and then wait until the API gives us a response, and then continue with whatever else we have to do afterwards. So this lets us do asynchronous processing in our apps. And then the return type of async function. So basically, when we actually build out implement integration with an API, we're going to be having methods that we're going to be writing functions that basically use HTTP library and then make calls to the API using that HTTP library, and then use the async part to actually continue the process flow once the response comes back to us. And then when we build these functions, the return type of these functions are going to be called futures. And these are kind of like promises in JavaScript. They allow you to specify return types with the async library. We'll go exactly into detail about how these things are used in the project in a few minutes. Okay, so the next thing is models. So when you build API integration, technically you don't have to build dark models. You can directly parse the JSON requests, the responses that you get from the API. But basically building dark models helps you keep track of your code better, and it also helps basically parse the JSON much more easily. So basically you can set up Dart models to specify JSON bodies in HTTP requests. And then you can also use Dart models to parse JSON responses into Dart objects really easy. So this makes it much easier to access data from API responses without making too many errors. And then the way we will be doing this is by basically including a factory method in the Dart models that we specify. And this will help us parse the JSON. Okay, so now we're going to move into the code. So the first thing I've done is I've set up a Dart model, and this is basically this basically encapsulates all of the different fields that I want to capture from our response. So looking back at our response, there's a bunch of different data, right? There's a list called prereqs, there's a list called coreqs, there's a course ID field, there's a description field, name, units, departments, and then there's a list of objects about the lectures and the different timings. But because I don't want to make this too complicated, hey, I'm just, yeah.
Sorry to interrupt. Could you make the text a little bit bigger?
Sure.
In VS Code.
Is that better?
Oh yeah, that's much better. Thanks.
Yeah, okay. So basically, we have a bunch of different fields in this response. But in this case, to keep things simple, and obviously you can build out models that include things like nested lists and stuff like these lectures fields. But in this case, we're going to be keeping things simple. We're just going to be showing the name of the course, the department it's from, the prerequisites, and then a description and the course ID, of course. So the way I've done this is I've basically set up this class called course. And then inside of it, I've specified the fields that I'm going to be capturing. So the name, which is a string, the prerequisites, which I've called a dynamic list for now. And then the description and department and course ID, which are all strings. And then I've set up the constructor. And then here I have what I was talking about in the slides, which is basically a factory method that allows us to parse the JSON really easily. So in this case, what it's basically going to be doing is using this JSON method and looking for this field inside of the JSON response, and then taking whatever is inside of that field and putting it into the name field inside of our course model. And likewise, these are basically all of the JSON fields that are actually in the response that it's going to be parsing into our model. Okay, so I've built the actual API call into this other file called api.dart. But going back to our user interface and going back into the actual pages I've set up for the screens. So like I said, we have this screen called the home screen, right? And what needs to happen is when you type in your course ID, it needs to capture this data, and then it needs to call the course API. It needs to get some information back, and then it needs to parse it to the next screen, which is course screen, and then it needs to display that for you, basically. So the way we do this is basically we have firstly, inside of our text field, we've specified what what I mentioned before, which is a text controller. And this is basically going to help us capture whatever's inside of the text field. And then the next thing, so this is all triggered when you press the search button, right? So Flutter, inside of the raise button widget, Flutter gives us what's called the onPress property. So basically what I've done is inside of onPress, I've said, so when someone presses the raise button, I want to call this method, which is onPress search. And then this method is an async function, like I said, because we need to call the actual API. And the first thing I do is I basically call setState, and inside of it, I set loading to true. So what this is going to do is it's going to set this Boolean to true. And then when I call setState, it's going to call build once again, and then repaint the user interface. And then remember that I specified the color of this button and the actual text, which is either loading or search, based on this Boolean value, which is loading. So when this becomes true, immediately the search is going to turn into loading, and the color of the button is going to turn blue. And then the next thing I'm going to do is basically capture the actual course ID from the text controller. So the text controller has a field called text, and that allows us to immediately get whatever is inside of the field. And then what I do is I have this object, the course object, which is basically what we specified in our model. And what it does is it's going to be calling the get course function, and it's going to be passing it the course ID that we got from our text field. Okay, so now let's hop into what this get course function actually is. So I've actually written this inside of api.dart. And here I have basically imported the HTTP library as HTTP, and I've imported the async library. And I've also imported this library called convert, which is going to help us convert, which is basically going to help us parse JSON objects. So in here, I have the base URL, and this is basically the base URL to the course API. And then this is the function I was talking about, which is get course. And as you can see, it takes in, a course ID string, and then it returns a future, which is a course. And it's an async function because it's going to be calling the API. And then in here, I've specified the exact URL. So it's going to be courses/course ID. And then I include the URL parameter that we need, which is the actual course ID that we pick up from the text field. And then I'm specifying some headers as a map of strings. And the only header we need here is basically an application JSON header. And then this is basically the main function that's going to call, this is basically the key line that's going to be calling the actual API. So I'm capturing the response that we're going to be getting from this API using the await keyword. And inside of the HTTP GET method, I'm passing the URL and then the headers. So what's happening is when you reach here, it's going to be taking the course ID and then building out the URL. And then we set up the headers, and then we pass the headers and the URL into the GET method inside of the HTTP library. And then it's gonna wait for whatever response comes back from HTTP, and it's gonna be putting into this spot. And then what I do is I access the status code field inside of this response object, which is built into HTTP, which is built into the HTTP library. And then if it's 200, which if you worked with REST APIs before means everything's okay, all good to go. I basically create a new object, a new course object, and then I decode the body of the response using the JSON.decode function, and then put it into a variable called data. And then I pass this data into the from JSON factory method that we wrote before inside of our course model. And then what this is going to do is, like I said, look at the JSON object and then basically figure out what data comes with this field name, what data comes with this field prereqs, and then so on, and then basically map each of those different data values to the actual fields in the course model that we created inside of here. And then I just return the course. And if it's not 200, I'm basically just returning a null here, but this is probably not the best way you could do this. You should probably like look at different responses that you might get and then build in other error messages and stuff that you might want to display. But for now, I've just built it to just return null if it's not 200, and if it's null, then it'll just display an error. Okay, so going back to the home screen. So we reached here. So now we've called the get course function, which is inside of the API.dart file. And then I'm passing in the course ID. And then if everything goes well, the function inside of API.dart, which is get course, is going to return the course data that we get when we call the course API with this specific course ID. And then as soon as I get that, I'm going to set state again. I'm going to call set state again, and then set loading to false. So what this is going to do is it's going to basically put search back inside of the button and make the color red again. And you may ask why I might need to do this, because I'm actually going into a new screen, right? So it doesn't make sense to actually set state again and restore the actual elements inside of this page. But the reason I'm doing this is because even though we push to the next screen, if that screen is popped, and if the user wants to return back to the screen, if we don't actually restore the loading Boolean, then what's going to happen is when they return, it's still going to show loading here, and that's not really what we need. Okay, so then what I do is if the course data is null, so I said if we run into an error, we pass null from the get course function. So if it is indeed null, then what I do is I call this function called show dialog, and then I display an error message saying we couldn't find the course with the ID. So for example, if I search an invalid course ID here, it's going to say we couldn't find a course with the ID 15. And this is basically, again, using one of Flutter's widgets. I've built a small function that paints a dialog box with an OK button. And that basically takes in a message and then prints out that message in the error message. And as you can see, it's using the alert dialog widget in order to do that. But you don't really need to worry too much about that right now. So if the course data isn't null, which is what we would expect, this means that the app is talking to the API correctly and is getting the data back. Then what we're going to do is basically we're going to be pushing this new route to the next screen to the navigator stack. And basically, in addition to creating this new route and pushing it, inside of the route, I'm specifying the course data that I want to send to that page. So like I said, inside of the next screen, which is course screen, inside of this class called course screen, I've added a constructor, and I've said that inside of this constructor, it's required that you send this course data object when you actually open up this class. So what I'm doing here is I'm getting the course data from the API, and then when I actually open up the new screen, when I create the new route and push it onto the navigator stack, I pass the actual course data that we've gotten into it because via the constructor, basically. And then, so in this case, this actual screen isn't doing any communication with the API because we've already gotten the data and it's just received it through the constructor. So all I'm doing here is just accessing the fields inside of the course data object that it received via the constructor, and then basically displaying it on the screen. So for example, the first text field, it shows a name, and this is going to be course data.name. It's the name field inside of the course data object that it got from the constructor. And then the department is another string. It's the department field inside of the course data model, course data object. And likewise here, I need to do something a little bit special. I need to basically take the prereqs, which, as you might remember, was a list, a dynamic list, and I'm converting it to string before I show the actual prerequisites on the in the text widget. And then finally, the description again takes the description field from inside of the course data object that we pass in from the previous screen. So that's all of the API integration. We're basically calling one API. All of it happens inside of this API.dart file. And of course, you can include this inside of your screens in any way you'd like. But the key thing is I'm using this future return type, and I'm creating an async function using this async keyword. And then when I call the HTTP, when I use HTTP.get to this URL, I'm using the wait keyword to ensure that the process flow stops and waits for this process to complete. And then after that, I'm accessing the status code, checking if it's all okay. And then I'm using the from JSON factory method to basically parse the JSON into a course model, basically a course object that we specified before. So are there any questions about any of this so far? Nothing? All right, I see a few questions on the chat. Okay, so Aditi asks, where is the data stored when we don't have a backend database set up? So in this case, we're not really worried about the backend because what's happening is the ScottyLabs API is directly sending data to us. But if you were to, if you don't have an actual backend database, then you won't be able to call an API and get the data. I don't know if that makes sense. But basically what's happening is inside of the Flutter app, we're not actually storing any data. Does that answer your question? There are ways to save data. So for example, if you want to have like a saved login, for example, there's a thing called shared preferences, and you can look into it. There's a library that you can use with Flutter that allows you to save certain values to the phone's long-term memory so that you can access it later on when the app is opened up again. But in this case, we're not actually storing any data inside of the app. All of it's done on the backend, on the ScottyLabs API side. Any other questions? So I think we're out of time. I've included some resources inside of the slides. So the demo code's in there, the catalog for all of the different widgets that you can use is in there. And then there's this site called pub.dev that you can use to search up and look up all of the different Flutter and Dart packages and libraries that you can use. And then the full Flutter documentation is linked here, and the ScottyLabs course API too, if you're curious about it, is linked here.